All right, so on to 13.3, geometric series. We're going to talk about finite geometric series. So what we're talking about here is, geometric series. So remember, a series means the sum of a sequence, and finite meaning we're looking at a certain number of terms. So the sequence doesn't go on forever, essentially. Really not much to talk about in this section, so I'm going to basically give you a formula that you need, and probably do a couple of example problems, maybe do some problems from the actual exercises as well. So, really the important things here, here's the summation notation again. So we're going from the first term to the nth term, essentially. They're using some different symbols that I might not use necessarily. But again, we see here that we're just talking about a sum, right? It's the first term, the next term, the following term, and so on. The formula that we actually need for this is going to be right here. So the sum of a finite geometric sequence, so the series, is a times 1 plus r to the n, all divided by 1 minus r. So a couple things to keep in mind here. A is the first term, and r is the multiplier, right, or the common ratio, and n is the number of terms. Now, in terms of the number of terms, sometimes there's a little tricky thing to think about here. So if we look back to this notation, the notation they're talking about here, they're writing the sum from 0 to n minus 1 of a to the r I, right? So starting value times multiplier raised to the exponent, and the exponent's going to keep changing, right? So for this, if I were to write this out as a sequence, this would be going just like the book is saying, right? We'd plug 0 in for I, and r to the 0 is 1, and so we would just be left with a. And this is a sum, so we're adding, and then we go to the next one, so I is 1. Put 1 there, and r to the 1 is just r, right? So a to the r, or a times r. And then a sum, so we add. The next one would be 2, and so ar squared, and then ar cubed, and we would keep going on forever. Not forever, sorry. We keep going on until a times r to the n minus 1. So until we get to this number, whatever this number is. So for example, let's say we're doing the sum from I equals 0 to 4. Okay? That's a 0 down there. It looks like it's a 0. And let's say the sequence that we're looking at is, let's keep it simple, 2 times 2 to the x. Okay? So in the summation notation, I'm going to replace my variable with the I. Fine. Okay? So what does this mean? Well, we're going to plug in all of these I values from 0 to 4. So essentially, it's 2 plus, because if I plug in 0, right, that part's gone, plus 2 times 2, that's plugging in 1, and then plugging in 2, and then plugging in 3, and then plugging in 4. Oops. Okay, so how many terms are we actually adding up here? 1, 2, 3, 4, 5 terms. So n, the number of terms, is 5. So notice what they're doing here is n minus 1. So that's where we got the 4 sort of from. I would be writing it in a different way. I would probably, instead of writing it this way, I would be writing it like that. Okay, because now I'm going to go from 1 to n, because in my mind it makes more sense to go from the first term, meaning I is 1, to the nth term. Okay, and then I would have to remember that that means if I'm going from, let's use fingers, right? Let's use fingers again. If I'm going from the first term to the fifth term, how many terms am I actually using? Well, 5 minus 1 is only 4, but we know that we're doing 5 terms, so I have to add that last term on. So that's one way to kind of think about it. There are two different ways, I guess, to think about it. But we can get the exact same thing, right? I can, in this, if I was doing this example in this notation, I would be writing it like that, okay? And that's one of the ways we've learned how to write sequences, geometric sequences, because we know that when we plug that first term in, we want it to be the 0th term, so multiply it. Hopefully you guys understand what I'm talking about here. If not, let me know. And we see that we would get the exact same thing, right? Okay, this was the general form, sorry. Let me go back to the general form. So this would be a to the r, a times r to the I minus 1. Okay. But of course that would be the same thing, because if I plug 1 in, it's just a, and so on. Okay? So two different ways to think about it. Let's use the formula to evaluate this example I just showed. So let's do 2 times 2 to the I, and we're doing from the 0th term to the 4th term. So how many terms are we actually doing? We're doing 5 terms. So that's why I like to use this notation from 1 to n, because then the number of terms is just right there on top. As long as I'm starting with 1 at the bottom, then the number of terms is right at the top. So let's go ahead and look at that. So if I'm going to do this sum, that's 5 of 2 times 2 to the I minus 1. And we're going to use this formula here. So A, what's the first term in this sequence? The first term in the sequence is 2. And then 1 minus, what's the r, what's the multiplier? That's 2. And then raise that to the number of terms, which would be 5. Divided by 1 minus the multiplier, 2. Okay, now we can go ahead and evaluate that. So, oops. We got 2 times 1 minus 2 to the 5. And we're dividing that by 1 minus 2, which is negative 1. 62. And so the sum here is 62. Okay, now that's what we would have gotten up here if we would have evaluated this, right? This is 2 plus 4 plus 8 plus 16 plus 32. Add those things up. We'll get 62. Okay? So, same thing. This is the formula we use. Really, that's it for this section. So let's just go ahead. Let's go down here and take a look at a problem here. So like number 1, how many terms are there in the series? And then find the sum. So let's go down here. Let's do number 1. Oops. Number 1. We have the sum from 5 to 18. So this is like from the 5th term to the 18th term of this sequence. Sorry. First of all, how many terms are there? From 5 to 18, the difference is 13. So there's actually 14 terms. So there's 14 terms. Okay? If we're going to use our formula, which is a times 1 minus r to the n over 1 minus r, we have to know the first term. That's the first term that we're adding. In this case, we're going from 5 to 18. So the first term is technically the 5th term. So we have to plug 5 into this to figure out what that is. So what we would do is we'd figure out what 3 times 2 to the 5 is. And so I'm just going to plug that in. 3 times 2 to the 5. And we see that's 96. So my a value is going to be 96 times 1 minus r, the multiplier is 2, and raised to the how many terms? 14. And then I'm going to divide by 1 minus 2. Okay, so now I'm going to plug that in. So I got 96 times 1 minus 2 raised to the 14, not 11, 14. That's going to give me that. And I'm going to divide it by -1, or, well, 1 minus r, which is -1. And so my sum is 1,572,768 would be the answer for number 1. Okay, and 14 total terms. So there's an example of that type of question. Let's do maybe a type of question from here. Let's do okay, let's do number 3. Let's take a look at number 3. So here's an example of a sequence in which it doesn't tell us what the actual equation is. So what we're doing here is we're finding the sum of the series. So we have to kind of figure out what our multiplier is. So here we see that our first term is 3. And then what are we multiplying by to get to the next term each time? Well, we're multiplying by 1/2. Right? You guys see that, right? Multiply by 1/2, and so on. So essentially we get this, okay? And so we are evaluating the sum from n equals 1 to, well, we got to figure out how many terms there are that we're adding up. So if we think of this, let me bring myself over here. If we think of this as the 0th term, right? And then multiply by 1/2 once, twice, 3, 4, and so on, right? This would be to the 10, right? The 10th. So from 0 to 10 is how many terms? That would be 11. So I'm going to put 11 on top. And I'm going to evaluate this. So using the formula, that's 3, the first term, times 1 minus r to the n, so it's raised to the 11, divided by 1 minus r. Okay, let's plug that in. 3 times 1 minus 1/2. I'm going to use decimal here so it's easier for order of operations. Raised to 11. And hit enter. And then I'm going to do 1 divided by 1 minus 1/2, which would be 1/2. And we get this value. We could technically turn that into a fraction. I don't know if the calculator will be able to. Yeah, it will. So there's our fraction. Our sum is 6,141 over 1,024. Okay? We just added a bunch of fractions together, and that's the fraction we got. That was number 3. Okay? So, yeah, I mean, and then the next type, determine if it's a geometric series, right? So figure out if there's a common multiplier, and if so, find the sums, right? Or whatever it may be. Writing the sums in sigma notation. Let's try it. Let's do one of those, I guess. I guess we kind of already went over that in number 3, but let's just do it again. 13. Let's do 13. So let's write that sum in sigma notation. So what's our multiplier? Our multiplier looks like it's -3, right? So there's my awesome sigma sign. And we're going to go from n equals, which, by the way, I like to use n instead of I, just because it's more comfortable for me. So I use n. From n equals 1, the first term, to how many total terms are there? Well, this one is kind of easy. I can just count 1, 2, 3, 4, 5, 6, right? 4, 5, 6. So I'm going from okay, wait, hold on. 1, 2. So what I want to do is I want to go to the 6. Sorry. Mind blanking. Okay. Sometimes I mess that up. All right. 6 terms, so the top is 6. That's why I use that notation. So the first term is 3, and the multiplier is -3. And then this is where I have to make sure I'm writing it correctly, because now it's n minus 1. Okay, so that notation just has to match with whatever form I'm using over there. I made it harder than it needed to be. So that's actually all it's asking me for. It's only asking me to write it in sigma notation. So that's it for that. Let's go with one more example. Let's take a look at 16. Let's evaluate that sum. So we got the sum from n equals 0 to 4 of 0.1 to the n. Okay, what's the first term here? Well, plug 0 in, and we get 1. 1 minus, what's the r value? 0.1 raised to the n. How many terms are we doing? This is starting at 0, so this is the one where you have to add an additional. So this is to 5 over 1 minus 0.1. Just evaluate this. 1 minus 0.1 to the 5, and then divided by, that's 0.9, right? 1 minus 0.1 is 0.9. I'm just kind of doing that step in my head. And we get 1.1111. There we go. All right, so that's it for that section. Let me know if you guys have any questions, and I will see you in the next one.